Hi, good morning, my dears. Welcome to today's session about force between two long straight parallel conductors. So, this is your today's session. In the previous session, we discussed about properties of magnetic field, Ampere's law, Ampere's law applications, Bio-Savart and the applications of Bio-Savart. Today we are going to see force between two long straight parallel conductors. We know that what is meant by conductor. Conductor is a device which is capable to flow the electricity. So it is access the flow of current from the body. It is giving permission to flow of current from their bodies. So that type of the bodies are called conductors. So here the conductor example is what? So as of we know that metals are considered as good conductors of electricity. So without wasting our time, we are going to the actual topic. What is the actual topic? Force between two long straight parallel conductors. Let's see. Let us consider two long straight conductors. So here the conductors are what? Two long straight conductors. The given name as one is the PQ, the other one is the RS. So PQ and RS are the two conductors. We are placed in what manner? They are placed in parallel manner. In where? In a vacuum or in air. Let us consider two long straight conductors. So the conductor of one is PQ, the other one is RS. Both the conductors are placed in parallel manner, and both the conductors of straight one, so they are in which standard? They are in straight nature. The straight conductors are placed in a vacuum, that means in a air. Then these conductors which are placed in a vacuum carrying some amount of current, the current is defined as I1 and I2. So PQ conductor, RS conductors which are placed parallel in a vacuum, they are having or they are carrying certain current. The current is considered as I1 for the PQ, I2 for the RS. So in a PQ conductor, the current is I1. In RS conductor, the current is considered as I2. So PQ, RS having or carrying carrying currents I1 and I2. When the current in the conductors are in same direction. So what is that? So whatever conductors we place in a vacuum, which are placed in parallel manner, if the conductor current is same direction, the conductors I1, I2. I1 is for the PQ, I2 is for RS. The conductors PQ and RS having current I1, I2. If the both the currents of PQRS means I1 and I2 are in same direction. I1, I2 are in same direction. Then these conductors exhibiting a particular force, that is nothing but attractive force. So what is that? Attractive force. What is the attractive force? Why attractive force existing? Because in these two conductors of PQ and RS, whatever current of I1, I2 is present, the I1 and I2 current is in same direction. Both I1 and I2. It may be clockwise direction, it may be anti-clockwise direction, but both the directions are in same. I1 direction, I2 direction is same. That is the reason between these two conductors, certain amount of force is existing, that is attractive force. What is that? Attractive force. You can see in figure. So this is about the figure. In figure you can see this is about the left one is a PQ conductor and the right one is a RS conductor, and in the left one, in the PQ conductor, certain current is generating or it is carrying current is I1. In RS, certain current is generated, that is I2. So I1, I2 are respectively in PQ conductor and RS conductor, and these two conductors are separated by certain distance, that is on separation distance. The separation distance is how much? The separation distance between these two conductors is r. When they carry current in opposite direction. Now you are saying, in previous figure you discussed this current I1, I2 in same direction. That is the reason there is a attractive forces existing. But if the current carrier conductors are having different directions, they are in different directions or in opposite direction, I2 and I1 are in opposite direction. What is that? If they are in opposite direction, I1, I2, if they are in opposite direction, so here the conductors shows a repulsive force. What is that? Repulsive force. I1 and I2 are not in same direction. Instead of same direction, they are in opposite direction. That is the reason between these two conductors a force is experienced. That force is a repulsive force. You can see the figure PQ with I1 current, RS with I2 current. But see the arrow mark. The arrow mark is away from the RS conductor. But in the previous, it is towards the conductor. Means from RS to the RS conductor is moving to the PQ conductor. But here, RS is moving from PQ. So this is a repulsive force. Let the conductor PQ, let the conductors PQ and RL carries current. Now I am taking only case 1, which is attractive force nature, which is nothing but I1, I2 are in same direction. Let us consider the conductors PQ, RS carry current I1, I2 in same direction, placed at a separation distance r. I1 and I2 is the current of PQ-RS conductors, and PQ and RS conductors are separated by certain separation distance, that is small r. That is what? Small r. So is this one only. So here let's see here the conductor RS, you are having a certain elemental length, that is the elemental length of this conductor is what? DL. The overall length of the RS conductor is L, but here what I am going to consider only small part of the RS conductor, that is DL. For this small part DL length, what is force? Small force, that is del F. So between AB points, certain length is there, that is DL or delta L. For the delta L a force you need to evaluate, that is delta F. Consider a current element AB. This is AB. A current element AB of length delta L. Of length delta L. The conductor, which current conductor? The conductor is RS. the magnetic field produced by current carrying conductor. So because of the RS in PQ the magnetic field is generated. So at the location of RS means an RS conductor that will be considered as due to the effect of the conductor RS a field is generated in the PQ. That field B1 is considered as mu naught I1 by 2 pi r. Mu naught I1 by 2 pi r. Mu naught I1 by 2 pi r. This is we consider as equation 1 or statement 1. Now consider Maxwell right hand rule. What is Maxwell right hand rule? This is Maxwell right hand rule. See, this thumb is indicating the flow of current, and these curved fingers or closed fingers, are indicating magnetic field. So this is indicating magnetic field. This thumb is indicating flow of current field. So according to Maxwell right hand rule, the direction of B1 will be perpendicular to the plane of paper directed downwards. Just see here it is perpendicular to I also. B is perpendicular to I also. So here the direction of B1 will be B1 is where it is a field which is generated in PQ conductor. So the direction of B1 will be perpendicular to the plane of paper if you are taking in the plane paper. So it is perpendicular plane of the paper and directed downwards. So this is about the Maxwell right hand concept. B is the field, I is the current, both are perpendicular to each other. So IB. Due to this magnetic field, each element of other conductor. So each element of other conductor. So PQ shows its experience on RS, RH shows its experience in PQ. So because of the magnetic field, in PQ you will get B1 magnetic field, in RS you will get B2 magnetic field. But here, because of this magnetic field nature, there is a experience will be generated on both the conductors. On the both the conductors, you can see a magnetic field B1 and magnetic field B2 on PQ and RS conductors. The direction of current element is perpendicular to the magnetic field. Just we already discussed. See, according to the Maxwell right hand rule, see this is between. See there is a right angle, means there is a perpendicular angle is existing. Perpendicular angle is existing. So here between B and I, perpendicular angle is existing. So here the direction of current element is perpendicular to the magnetic field. Perpendicular to the magnetic field. Therefore, the magnetic force, therefore, the magnetic force on element AB with length dl. So we are talking RS. Just on RS we already consider certain point, that is the AB point. For the AB point certain length is what? Delta n. So the magnetic force on element AB of length delta L is considered what? So the magnetic force is considered as delta F or del F equal to B1 I2. I2 is what? The current in RS. I2 delta L, the length of the RS for the smallest length. Sin theta. What is sin theta? Sin 90 degrees, because perpendicular character. So 90, sin 90 is 1. Then replace the value of B1. What is B1 value? B1 is nothing but, we already took that one, mu naught I1 to pi r. Mu naught I1 to pi r. Replace here, then simplify. Sin 90 is 1. Thereafter, you can see here mu naught I1 to pi r. I2 is remains same, delta L is remains same, sin 90 is 1. Then the place of B1 we replace mu naught I1 by 2 pi r. I2 remains same, sin 90 is 1. Therefore, del F is mu naught I1 by 2 pi r 2 pi r into I2 del L. Therefore, the total force on conductor length, the total force on conductor of length is what? It will be defined as F equal to mu naught I1 I2 by 2 pi r into total length, that is summation of del L, which will be simply considered as L, which will be simply considered as L. Therefore, F equal to mu naught I1 I2 by 2 pi r into L. This is your topic. What is your topic? The force between two parallel conductors, the conductors carrying current. The conductors are carrying current to which current to they are carrying current is their carrying current is I1, I2, and they are separated by a separation distance, that is R. So this is about the our task. Okay. Now somebody is asking that one. What is the force per unit length? What is the force per unit length? The force per unit length is force acting per unit length of a conductor is considered small f equal to F by L. Small f equal to F by L, which is nothing but mu naught I1 I2 by 2 pi r. Mu naught I1 I2 by 2 pi r. This is only force between two conductors. Force between two conductors. This is force acting per unit length, per unit length, per unit length. F by L mu naught I1 I2 by 2 pi r, where I1 is the current in PQ conductor, I2 is current in RS conductor, R is separation between PQ and RS conductor, L is length of the conductor, F is the force. So this is about the force between two parallel conductors or force between current carrying conductors. Current carrying conductors. Here you need to assume only one aspect here, that is Maxwell right hand rule. What is Maxwell right hand rule? So the Maxwell right hand rule is nothing but this is Maxwell right hand rule. When you take a conductor in your hand, around the conductor, whatever closed fingers are there, they are indicating the direction of field or the magnitude of the field. The thumb is indicating flow of the current or direction of current. This is the Maxwell right hand rule. So, by using Maxwell right hand rule, we are evaluating the current carrying force. So, here this is the task. Okay. So what is task here? Our task is b1 equal to so we in this concept we are introducing some equation, that is b1 equal to mu naught I1 by 2 pi r. So this is equation 1. b1 equal to mu naught I1 by 2 pi r, because of rs in pq a field is generated, that field is b1. So mu naught I1 by 2 pi r. So again you are considering Maxwell concept. Then again we establish this equation here, sin 90 is 1. So after simplifying you are getting mu naught I1 I2 by 2 pi r into L. This is the force between current carrying conductors. Thank you.